Okay, so today's topic is going to be a review of functions. You have probably already done this in Algebra 1. You have done it in Algebra 1, but you may not remember the ins and outs of how to work with a function. So the first thing we're going to deal with is a relation that we have a function? So a relation is just a set of inputs and outputs, and they are usually written as an ordered pair. You're going to have to forgive my bad handwriting. I'm using an old stylus on an old iPad and it's not working. Ordered pairs you've usually seen written as an input and an output. So if we put a value into the function, it's going to the function is going to change it around and make it into a different output. And we usually will write this as x, y. There are lots of different ways that you can show a relation. So the way that students usually like the best is with a table. We can also use a graph to show this, or what's called a mapping. So if you remember a mapping, it involves ovals and arrows and showing how one number changes into another number. And the last way is with what we are commonly use is with an equation. So for example, right here we've got a set of ordered pairs, right? And the domain is the input for each ordered pair. So in this case, the domain would be all the x values, 1, 2, 0, 2. And the range would be all the y values, 3, -7, 5, -8. In mathematics, we usually call the number that we're putting into the function, the something that we don't have any control over, the independent variable. And this number or the range, the value that the number changes into, is what we would call the dependent. So these numbers over on the left-hand side are what we call the inputs, and the numbers over on the right-hand side are what we call the outputs. So how will this look? We're going to look at a relation here, and we're going to show the different ways that it could be represented using a table, a graph, a mapping, and an equation. So first of all, let's see if I can move this up a little bit. So we've got a set of numbers here, a set of ordered pairs. If we wanted to show this as a mapping, what we need to think of it is that all the inputs, these numbers right here, are going to change into all of the outputs. So if I was going to map that, I would take those numbers that were my inputs, 0, 1, 2, 0, and 3. And I would write them over here. You'll notice that I've only written the number 0 one time, because once a number is written into a mapping, it does not need to be duplicated. So I've got 0, 1, 2, and 3 over here in my input circle of my map. The output is going to be all the numbers that the input changes into. So 0 changes into -2. So over here we've got a -2. And we've got an arrow drawn between 0 and -2 to show that 0 in this function changes into -2. 1 changes into, 1 will change into +2. So we've got 1 and +2 with an arrow between them. 2 changes into 1. And 0 changes into 1 as well. Now you noticed back here that 0 could change into -2 and 0 could change into 1. That means that 0 has two options. If we put that number into this, if we put 0 into this relation, sometimes it'll turn into a -2, and sometimes it'll turn into a 1. So you'll notice that I've got my 0 over in my inputs here, and that I've got an arrow drawn to show that it sometimes turns into -2 and sometimes into +1. So this mapping represents the relation that we have up here that's written in ordered pairs. How would we graph it? Well, you guys have been graphing ordered pairs for a really long time now. So to graph ordered pairs, you just do the xy coordinates on the coordinate plane. So you just graph each xy. So for example, the first one is 0, -2. So we would go over 0, down -2. That's that point. A table takes all these points and just writes them in your ordered pair form. So we'd have like 0, -2 becomes this entry in our table, 0, -2, 1, 2, 2, 1, etc. So how do we know if this relation is what we call a function? The mathematical definition of that is a function is a relation in which each input, which is an x value, only has one output, which is a y value. In other words, if we put an x into this function, if we put an x value into this, we know for sure that there's only one possibility for the output that we're going to have there. So in other words, x values cannot repeat or have different y values. So let's go back and check. Was the relation that we had up here a function or not? So let's look. When I put 1 into this function, I know for sure that I'm going to get 2. If I put 1 in, it changes to 2 every single time. That x has one y. What if I put 2 into my function? When I put 2 in, I only get 1. That's okay. If I put 2 in, I know for sure that I'm going to get 1 out. What if I put 3 in? I know 3 is going to change into 4. That's great. But what if I put 0 in? If I put 0 in, what happens? Well, sometimes 0 is going to change into a -2, and sometimes 0 is going to change into a 1. So what that means is the input value of 0 does not have only one output. It has two outputs. Since x equals 0 has two outputs, my two outputs are -2 and 1. This relation here is not a function. Not a function, because an x value of 0 has two outputs. So was this relation a function? No. The input 0 had two different outputs, -2 and 1. So how does that look like in a graph? Well, in the graph below, it's kind of hard to see. Let me see if I can make it look good. Here's the original graph that we're starting with. Here, and then this guy looks like that. So if you remember from Algebra 1, the way that we tested to see if something was a function was what was called the vertical line test. So the vertical line test says, if you've got a relation, every vertical line you can draw goes through the function only once. If it only goes once, then it's a function. If a vertical line goes through 2 or more points, it is not a function. So we need to decide if these two guys are functions. So let's look. We've got our first graph, this red graph here. If I draw vertical lines through that graph, it touches once, it touches once, it touches once, it touches once, it touches once. If every vertical line goes through the function only once, then the relation is a function. So we would say, yes, this guy is a function. What about him over here? If I draw a vertical line through him, Here, it only touches once. But over here, it's going to touch in two different spots. And for that reason, we would say this is not a function. The real reason is that an x value of, for example, it looks like that's about 1. So it looks like this graph passes through the points 1, 3, and 1, 1. That's 1, 3, and that down here is 1, 1. If I have an input value of 1, I have two different outputs. Sometimes I get 3, and sometimes I get 1. Therefore, it is not a function. Okay, so let's go over to the other side of your paper, and let's look and see if we have relations that are functions or not. And then we're going to try to make a mapping of each of these functions, or relations, I guess I should say. So state the domain and range of the following graphs. Well, if we're going to state the domain and range, then we need to know what those x coordinates are of all those points. So I'm going to zoom in a little bit. I'm going to try to zoom in a little bit on this graph. It's a little blurry, sorry for my bad picture here. And we're going to do the coordinates of each of these points. So for example, this point is -3, 1. And this guy up here appears to be 0, 4. This is 2, 1. 4, 0. 5, -4. And this is -1, -1. So we want to decide, first of all, what is the domain of this function? So if you remember, domain is the set of all the x values. So my x values are going to be these first numbers. So I'm going to write those in order. -3 is the smallest. -1, 0, 2, 4, and 5. That's my domain. What about my range? Well, range is going to be all the y values. So let's see. From smallest to largest, I've got -4. You'll notice that -4 is in two spots. I only need to write it once here. 0, 1, once again, is in two spots. And then 4. So that's my domain and my range. Now let's try to decide if this is a function or not. So looking at this graph, we can tell if a graph is a function by seeing if we pass a vertical line through it, if it will only touch once, or if we tell if each x only has one y. So let me go ahead and make my mapping. Maybe that'll make that a little more clear. I'm sorry, guys. I'm using very old technology here. It's not working great for me. So we're going to place all of our domain values over here. -3, -1, 0, 2, 4, 5. And my range over here, -4, 0, 1, and 4. To make this into a mapping, we need to draw arrows to show what my input changes into. So -3 changes into 1. So I'm going to draw an arrow between -3 and 1. -1 changes into -4. 0 changes into 4. 2 changes into 1. 4 changes into 0. And 5 changes into -4. So this mapping right here would represent this situation. Now we need to decide if it's a function. So when you're looking, we want to look, are there any x's that are repeated? And it looks like all of my x's are different. Now, we do have some y's that are the same, but that's okay, because we know that -1 every time is going to change into -4. It doesn't matter that 5 would also change into -4. As long as none of my x's are repeated, then we would say, yes, this is a function. Let's do the same over here with this graph. So we're going to have all our ordered pairs. This looks like it's going to be -4, -4. This is -2, 0. This one is -1, 1. Up here we've got 2, what is that, 4? 1, I'm sorry, 2, 1, and 4, -3. So let's go ahead and state our domain and our range. Our domain for this graph is going to be my x values. So -4, -2, -1. 2 I only need to write one time even though it's in two different spots, because once you've written the number 2 it's considered a value there. So that's going to be my domain. And my range of course will be on my y values. So -4, -3, 0, 1, and 4. Let's go ahead and try to make our mapping. So we're going to put our domain values over here, -4, -2, -1, 2, and 4, and our range values. And we're going to draw our arrows. So it looks like -4 goes to -4, -2 goes to 0, -1 goes to 1, 2 goes to 4, 2 also goes to 1, so 2 could change into 4, or 2 could change into 1, and 4 changes into -3. So let's talk about this kind of interesting point here, where 2 could change into 1, and 2 could change into 4. For the input value of 2, we have two different outputs. We have a repeated x value that has two different y's. And so what does that mean? That means that this is not a function. If we looked at our graph, we would see that it would fail the vertical line test right there. If we drew a vertical line through that graph, it would touch in two spots, therefore not a function. Okay, for our very last part, we're going to look at some graphs, and we are going to try to write the domain and range and decide if the relation is a function or not. Usually when we write domain and range, we will do so with what are called inequalities. So a less than sign to indicate what values the x's are between and what values the y's are between. So this can be kind of hard for kids. But if you practice and think about it, usually you can get the hang of it. So domain is the set of all x values. Now if I wanted to, I could write all the ordered pairs that make up this value, this function. But it would take me forever because there's infinite points in between there. So the question is, what do my x values go between? So if I look at this graph, I can kind of draw a line here and here. And I can say that all of the x's that I have are contained between these 2 points. It looks like that smallest number back here is -4. There are no x's that are smaller than -4. So -4 is the smallest x that I would have. All my x's are bigger than -4. And what's the biggest that they can get? Well, it looks like it's all the way over here at, what is that, 5? So all my x's are contained within -4 and 5. We can do that same thing for range. Erase these here. Only this time, we don't want to use vertical lines. We want to use horizontal lines. So we're going to draw a line up here at the top that is the absolute highest point that this graph goes, and a line down here at the bottom that is the absolute lowest point that this graph goes. Now remember that range is y's, and so your y values are going to be contained between -5 and 4, because -5 is my lowest y value and 4 is my highest y value. Is this relation a function, yes or no? Well, we'd need to look at the vertical line test. So as I pass some vertical lines through, it looks like they will only ever touch one time. And so we would say, yes, this is a function. So let's try something similar over here. This graph is a little bit different because you'll notice that it has arrows at the end. So what does that mean? That means this graph goes on and on and on and on and on and on and on. Forever and ever and ever and ever and ever. In the x and y direction, in the x direction, I am not able to draw a line that contains the end of this graph because this graph is infinite and it continues on and on and on. And so there's no way to be able to draw a line to say all my x's fit in between here. So mathematically, we would say that my domain here, erase this, make it easier for you to see, is all the numbers in all the world, every number in the whole world. So with an inequality, you can write that this way. Negative infinity is less than or equal to x, which is less than or equal to infinity. You will also see that written as all real numbers. And the mathematical symbol for all real numbers is this capital R with like 2 lines on it. What about the range? Well, this graph goes down, 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 down forever and ever and ever and ever and ever, right? But does it go up forever and ever? No, it doesn't appear that it does. It looks like the biggest y value that I get is -2, and everything else is below that. So I'm going to say that my range values are all the y's from negative infinity up to -2. Is this relation a function? Well, if I pass vertical lines through it, it looks like they only touch once, and so we would say, yes, this guy is a function. So let's look at our very last one down here. We've got a line that is infinite in both directions. For our domain, we are not able to draw a line on either side and say that there's no points after it because that line is going to continue on forever and ever and ever. So here we would say that our domain is all real numbers. Because this line is infinite up and down, we can't draw a line above and below either because it will continue to pass right through it. And so our range is also all real numbers. Is this a function? Yes. And what about this last one? Well, he's a little more contained than the other ones were. So our domain looks to be that there's no x's that are going to go past that boundary. And that boundary is -1 and 5. So all my x's are between -1 and 5. All my y's are between -5, because that's the lowest point here, and 1, because that's the highest point. And we would say that this is not a function because it would fail the vertical line test. If I passed a vertical line through, it would touch in more than one spot.